Hello everyone, it's July 27, 2022. Is Geo Rant time, Geo Rant number 175. That's the title, pointing to the title, not the cat, that's Huck. Speaking of cats, today would have been my white cat, Katenatron's 15th birthday. She died November 11th of last year. Makes me sad. Remember the things. Anyway, before I digress, a geologist's interpretation of a rock outcrop on Mars. And many of you may recognize this photo. It's from the Perseverance rover. We are going to assume this is the context. A single photo from a single location that is not disclosed. And a lot of you send me pictures of rocks. Some of you do context, which is nice. A lot of you just send me a picture of rock and go, hey, Steve, what is this? And that's not something that can be done reliably from just a photo with no context. And this, even though this is an outcrop, I'm going to show you how difficult this can be, maybe at this scale. Now, quick note here. This is a rock outcrop. Most of us geologists would call this an outcrop. We wouldn't refer to this as a rock formation. Why is that? Well, because formations in geology, unlike geomorphology, in geology, a formation kind of clues you into the fact that it's a lithostratigraphic formal unit. All right. And you guys have heard me talk about that before. Like if you see something that says, the Lorraine Formation, or something like that. That's what we tend to think of. So to separate the two, we're going to call this an outcrop. And in my notes, if I walked upon this, I would say outcrop whatever. I wouldn't say formation whatever. All right. So, okay, you see this here, and we look at this. This is a picture. All right. And people are like, well, it's sedimentary rock. More than likely it is. And there's neighboring photos and stuff like that. It probably is, but we're going to assume we don't have anything else. All right. We're looking at this photo. I'm going to take you to the upper left first, then kind of the middle of it there, and then kind of the bottom just to show you, walk you through how difficult this actually can be. So, okay, so now here we're at the upper left, and you see these thick beds. You see it's bedded, and I said this in the last Geo Rant. You can have beds in igneous rocks, all right? So just because you see bedding doesn't immediately mean sedimentary. Although there's some things in here from a distance that does kind of clue in that this whole thing might actually be sandstone. But you can see kind of some porous parts and stuff like that on it. But that doesn't mean it's a sandstone. I can show you porous basalts up in the UP. And Mars has this little coat of rust on it. But as you can see kind of through here, the rocks look gray. Sandstones can be gray, but so can basalts. So you can't discern that this is definitely a sandstone just by looking at everything. I mean, it probably is, but it's thicker bedded than the underlying stuff. I guess this could be a surface flow. We don't see anything below that kind of smaller ledge that would indicate a bake zone, but the whole thing's in a CO2 atmosphere with a yellow hue anyway, so we can't really tell from here. But we do see that it looks, I don't know the scale. That's another problem. There's no scale, but we'll assume this bed towards the bottom is maybe, 10 centimeters high. That, and the ones above it kind of look like, this could be even an igneous flow or a couple of them. Now, it's nice to sit there and pull our experiences from Earth and just directly apply everything to Mars, but it may not be totally doable. Like some of these formations on Mars likely are very much thinner than they are on Earth. Earth can accumulate thicker geologic formations because we have active tectonics. Mars does not, and probably, well, it probably had some sort of tectonics, but nothing like plate tectonics or anything like that in order to give you big, thick sediments. So this entire thing you see in this picture could be one lava flow, even though it's like a meter plus a little bit thick, all right? Or two or three. Okay, so let's go to the next one. Now we're moving to the middle. You can see the bottom of the thickest bed. Now you look here and you do see that the bedding is much thinner, but in some places you see it's a little thicker and almost lenticular. Oh, thunderstorm. That's a key indication that this probably also is a sandstone. And, but we can't just come to that conclusion. I mean, there could be really thick mudstones. There could be carbonate in here. This could be a little tiny sill of igneous rock. There's so many things this can be in the near dead center here that, we can't just assume that, oh, yeah, this is a sandstone because I took a picture of it. All right. So you see the beds get thinner. And we come back to the whole concept of the thing here to begin with. So the beds don't really look cross-bedded that much. I thought I saw some somewhere, but maybe not. But this lenticular nature of this bed in the middle kind of shows you that there's bedding going around it. So something a little different was going on. You get warped beds around intrusions too sometimes. So, you can't just say the whole thing's sandstone. Now here we're at the bottom, and you can see that we still have thin bedding, and here's that near the upper left is that thick lens that you saw previous slide. And down here you see the slope of sand, and you can kind of see the gray through the red. And you can see it slopes. That slope is probably, it's not 45 degrees, but it's probably 35. These rocks themselves, I can't tell the actual dip. And I'm assuming I'm looking along strike. If I'm oblique, this dip analysis could be completely wrong too. This could be dipping a lot steeper this way, and I'm just looking oblique. But we'll assume I'm looking down strike here. Let's do it that way. Looking down strike. And that's probably a 20-degree dip, something like that. And by this down here, we can tell the sand can hold its own, its angle of repose so it doesn't just fall, can be pretty steep. That brings us into the interpretation of this. Now, a lot of people just want to go, oh, yeah, this is obviously water lane, but it's not obvious. Okay. And like I said in my last Geo Rant, these beds they might actually be dipping this way. That's what they kind of look like. Anyway, um, you see, this bed here is correlative to this bed. You've got running down the middle right here, you've got that where the sand goes up. You've kind of got a recess there. So you got to take 3 dimensions into account. There's no fault here. Okay. It's just you're looking at it from a low angle without being able to see over here. So, um, I just thought I'd note that. So you look at this, you might be like, oh yeah, it's water lane. But you got this high angled sand on here. You can get windblown aeolian deposits at angles like this. That's not unheard of. All right. And you could have a couple overlapping dunes, and you look at it standing back, and you can see kind of in the middle, there's a general lenticular shape encapsulating that lens in there. Now, it could mean fluvial streams, but it's not necessary. Or you could have a dune that had a little fluvial stream on it and then got buried by another dune. The point is, this doesn't have to be like a marine environment laid down following Steno's laws. This could be a wind-blown terrestrial deposit. That is sedimentary, but it's not the kind of thing that's going to go burying lots of fossils if there are any on this planet or not. So it's not a good place for that. But if it is marine, like if this top stuff is or is a sandstone, say the stuff below it, the thinner bedded stuff has a lot of calcareous parts, a lot of limestone in it, or it's a calcareous sandstone, that probably means it was put down horizontally and has been tilted. So we have some tectonic action here, which we can't tell direction or what was going on from where or what. If this is like the limb of a syncline or it could be a syncline, could be an anticline, or if there's a fault in there. So we can't tell any of that from this picture. So our information that we can gather from this is extremely limited. The only thing we can say for sure is, yeah, we want to jump immediately to this as a sedimentary rock, and it likely is. But the only thing we can say for sure out of this picture, with no context, no analysis, is that this rock outcrop expresses distinct bedding. That is all I can say with confidence, with 99% confidence. Okay, I can't Everything else I've talked about is pure speculation and conjecture. Okay, you would need to actually go up to this rock and break a piece off and look at it under hand lens, or do the pew pew thing with the libs thing to get at least your elements out of it. But you can't sit there and just draw massive conclusions from this one rock outcrop with no context. So that's now, I hope this kind of forms a picture in your head why just sending me random pictures of things gets me thinking in my mind that it's not as easy. I mean, you might just sit there and think, oh, yeah, this is a rock or something. It's got to be one particular thing. But rocks can form in different environments. A lot of rocks can look like other rocks. And that's why those of us who know this stuff get when we see stuff like that. Okay. But so this is just kind of a little more grandiose, exaggerated example of that because it's Mars. All right. And like I said, I don't know the geology of Mars, but I know the geology of Precambrian rocks on Earth. So, I mean, our tendency is to see patterns in things and stick them with our familiarity and what we've experienced. And, so we want this to be a lot like processes on Earth, but that doesn't mean it is. All right, so remember that too. Anyway, we're coming up on 12 minutes here. Anyway, that's it. If you have any questions or comments, please leave them below, and I hope you learned something.